Our next topic in statistics is called correlation. So it's two topics called correlation and regression. So we're going to start off with just an introduction, and then the video after this will be some numbers. And it's a lot of numbers, it's a lot of calculation. It's not tough, it just takes some time. All right, organize your data into columns, get some numbers. We want to get a value when we're done. All right, so we're going to talk about correlation. So we're going to use the letter R now, lowercase r. And that represents Pearson's sample correlation coefficient, okay? It's named after the man Carl Pearson. And R has a numerical value somewhere between -1 and +1, all right? And what does R do? R measures the strength of the linear relationship between X and Y. All right, so you've plotted points before, right? 1, 2, to the right 1, up 2. Right? You've done things like that before. So we're going to do it that simple. So I made a little graph over here, and this is just a fake set of data, but it does kind of make sense with what we're talking about. All right, so across the x-axis, I have for high school students GPA. And on the y-axis, I have their accompanying ACT scores. So I have this person that got a 2.0 for their GPA, and they had 19 on their ACT. And another person had about a 2.2, and they got a 24 on their ACT. Here's a person with probably a 28 and got a 25 on their ACT. Here's another 28 and got a 32 on their ACT. And then we have somebody that got close to a 4 point. We're going to say 3.75 GPA. Got a 30 on their ACT, and the other person got a 36, which, as you know, is the best score possible. So we want to know, is that a strong relationship? The points aren't making a line, are they? But our goal in this section, or in this topic, is to try to see how strong is this relationship and what's the best line that we can use to determine what these points represent, okay? Or we can predict from that, all right? So in other words, we can say, well, what if I have a 2.7? What should my ACT be? I go over to 2.7, I go up here, oh, you should have about a 29, okay? So a positive correlation, let's get some graphs here. A positive correlation, right, has a positive slope, all right? So if I make a graph in quadrant 1, which we tend to be in, and if my points look like this, that would be a +1 for R. R equals +1. Notice how it slopes in the positive direction, right? It goes uphill. And they kind of line up, right? They look very linear. Our next one, let's do this one, and let's have some points. This time, they're going to go downhill. Now, the slope doesn't matter as long as it's a negative slope. It doesn't have to be a slope of 1. It just has to be a negative slope. So those points are lined up, and they're going downhill, right? From left to right, the slope is negative. That would be a correlation of -1. So what does that mean? As my smaller values are large, as my x values are small, my y values are larger. And as I increase in my x values, right, my y values decrease, all right? So think of some situations like that. This one's pretty easy, height and weight, right? The taller you get, the more you should weigh, right? A really small person can't weigh as much, right? A really tall person can weigh more. So height and weight. On the other hand, what could be something here? This could be hours studied, right, and number of questions wrong. So didn't study at all and missed 10 questions. Studied a lot, missed 1 question, all right? So the more you study, the less you get wrong. Our third one is sometimes just kind of randomness, all right? So we're going to do what? When R equals 0. So I've got some points, and they're just gonna be scattered around, right? I can't make a line out of that, right? I don't even know if it goes down or up to predict it, but we're gonna say R equals 0. Pretty close to 0 for that one, okay? It's pretty random. So I've got 3 types of things. I've got a very strong correlation. I have a very weak correlation. And I have randomness, right? No correlation. So I like to have a little scale with this, and my dividers are the 5s and the 8s. So here we go. So if I have a spectrum here, and this is -1, and this is +1, and this is 0. And let's divide that up with -0.5, +0.5, -0.8, +0.8. So I'm going to say anything that lies out here in the extremes, from the -0.8 to -1, we call that a strong linear relationship. Now it can be 0.7, we're not going to get upset, but it has to be way out there. This is a strong positive linear relationship. Then from the 0.5s, right, from the -0.5 to -0.8, I'm going to call that moderate, right? That's another word for medium, moderate. So that's a moderate negative linear relationship. And between 0.5 and +0.8, that's a moderate positive linear relationship. Then everything between the 0.5s, from -0.5 to +0.5, we're going to call that weak. That's a little more scattered, right? That's weak. So anything with an R there, we're going to call that weak. So our next video, we're going to figure out how do you calculate this R, okay? So it doesn't matter what is X and what is Y. If I flipped this over, right, and had ACT as my X-axis and GPA as my Y-axis, R is still the same value. If I flip this graph, right, with my X's and my Y's, R will be the same value. So R is just the linear relationship, the strength between the X's and the Y's. So it doesn't matter which is X. So you're not going to mess up there, choosing the wrong X or choosing the wrong Y, all right? So to find R, it doesn't matter what's X and what's Y, okay?